Thank you very much. And I am thrilled to introduce our next speaker. Carsten is truly an extraordinary individual. He has been working at the forefront of AI since he was a teenager. He's been releasing a new patent every year for the last 3 years. And I'm sure you'll be moved, maybe haunted by his insight. Thank you very much, Carsten, for attending. You have the floor.
Okay, thank you very much. Hello. Well, I'm not going that deep into technology today. I don't have enough time for that. Of course, as it was said before, you can also contact me by LinkedIn or by other means. Unfortunately, I cannot attend live today, but I will be on Rise of AI next week. So maybe we meet there, or else you could just connect me on LinkedIn. So today I'm going to talk about common misconceptions on AI, and that's important because there are so many things which are said now about AI because everybody wants to talk about AI, and some of these things are not right. And the difficulty is if things are not completely right or wrongly extrapolated, what happens is that things might look good, but they will not work as desired. And in some cases, this is just a small things which you can fix easily, like this one. But in some cases, actually, these errors lead to a lot of cost when you want to correct them. So some common misconceptions about AI, and I will not start with technology. The first misconception is, I know AI. I studied it 20 years ago, 10 years ago, even 5 years ago. Many things have changed. And Heraclit, more than 2,000 years ago, said, nothing is more constant than change. But today, Heraclit is wrong. Change is not constant anymore. Change is changing. And actually, what is changing is the speed. Change is accelerating all the time. And AI changes really rapidly. So when you look at this timeline of AI, you will see a lot of things which happened until the year 2000, or some things. Of course, there were many more inventions. And then there was kind of a gap between the year 2000 and 2010, and that's called the AI winter. But in this gap, two very important things have been invented. That's the ReLU activation function. You don't have to understand this, even though it's not so difficult. And the CNN has come to let's say, adulthood. So CNN is convolutional neural network, and the CNNs were the things that enabled computer vision then in 2012 to suddenly beat all other computer vision things with AI. So all computer vision before 2012 was non-AI based, or every experiment they made with AI didn't work well. And since 2012, AI took over, deep learning took over, and neural networks took over because of the advances in CNN and with the ReLU learning function, activation function. So, and now you see what happened since 2010, actually since about 2013, things sped up. So after this 2012 computer vision with AlexNet, and now new papers with very relevant findings come out every month. I will just go through 3 very important innovations which happened in the last 10 years very briefly. So these are the 3. So it's GAN, generative adversarial networks, deep reinforcement learning, and transformers. All 3 bring new possibilities to AI, which before were not thought that AI could be able to do these things. So let's take a look at GANs. So how it works is there are 2 networks playing against each other. One tries to build something, and the other one tries to find out whether the picture or the construction or whatever was built by the first one, or whether it was taken from an external source, so basically built or constructed by humans. And these GANs have brought a lot of things to us because they enable the computer to be creative, to design something on its own. The thing that comes mostly to mind is deep fakes. which have been invented in 2014, and since 2019 they're indistinguishable from real pictures. But it can also like draw. This is the town of Tübingen, and it's in the style of the drawing of Vincent van Gogh, who never was in Tübingen and didn't paint this. It can also make up the details of a picture. So when you have, like, let's say, a holiday picture, and then in a small part of that holiday picture, just like this tiny part, there's this leopard, and when you enlarge this, then suddenly it becomes blurred, like on the left side, because there are not so many pixels in the original picture. Now with GAN technology, suddenly the leopard is reconstructed in a way and enlarged in a way that looks very live, and so you can use this for enlarging blurred pictures. Also, one of my own companies, Casablanca, which turns the heads in video calls. I've currently not switched it on because I'm looking around anyway, but so normally you look at each other like this, and with Casablanca, you suddenly look at each other like that. And we use GANs to paint parts that the camera cannot see. We turn the head for a different camera position, and so like underneath the nose and underneath the chin, the camera cannot see when it's above, and we construct this with GANs. But also GANs can construct 3D things, and they're used in generative design. This is a separation wall in an aircraft, and this separation wall looks a little bit strange, but it has the same strength as the walls before, which were just flat. And this one is 30 kilograms lighter per wall, which saves Airbus 166 tons of carbon dioxide per aircraft per year. And this was constructed with generative design, which also uses GANs for part of its work. Okay, deep reinforcement learning. So GANs do creativity with the computer, and like 10 years ago, people said computers can never be creative, they can only do humans tell them. Deep reinforcement learning, this is the next thing, strategy. So computers cannot devise their own strategy, they can only do strategies that humans tell them. This was the case in 1997 when Deep Blue, the computer built by IBM, won against Garry Kasparov. This was not a computer teaching itself chess, it was dozens of chess grandmasters telling programmers how to do it, and the programmers programmed it. And the computer did only have the strategies that humans gave them. But this is not the case anymore. With deep reinforcement learning, a much more difficult game than chess, namely Go, has suddenly been won in 2016. And actually nobody believed that this could ever be, not nobody, but many people believed it could never be won by a computer. And this was because in deep reinforcement learning, it was possible for the computer to play against itself and learn strategies from that. And with the same technology, it's not only for games, with the same technology, AI devised a strategy to calculate matrix multiplications faster. And something that mathematicians have worked on for a while, and AI has found it much faster, the solution. And also a very important breakthrough for medicine is AlphaFold. So this is for proteins, finding out the three-dimensional structure of proteins in the body, very large molecules containing thousands of atoms. And when you have thousands of atoms, you need to know how the three-dimensional structure is, because only the outside of the molecule can interact with the body. Everything that's on the inside of the molecule cannot interact with the body. So you need to know the three-dimensional structure to build medicine out of it. And about 100,000 of these protein foldings were known before AlphaFold, and AlphaFold discovered the remaining 99.9%, so 100 million structures, and actually they structures of three-dimensional structures of proteins, and they also gave it to the public domain, so pharma companies can use it to find out new cures. So the second very important learning, deep reinforcement learning. The third thing is transformers, and you know about this because this is the foundation of ChatGPT, and everybody has heard about ChatGPT right now. So what you can see is these things have happened within the last 10 years, and and they were faster than anybody expected, and the world is really speeding up. Now, the next 4 things will be faster than number 1, but I probably take 15 minutes, not 10. Number 2, AI should be left to the AI department. This is a very important misconception, because if you when you leave AI completely to the IT department, you will never get the connection between business or your products and AI, or it will be very hard. So later, all the details can be handled by AI experts, but the principal ideas must come from domain experts, which are often also in the company, the leaders of the companies. In order to get those ideas, those leaders and domain experts need to get some AI knowledge, some fundamental AI knowledge, to understand what they could possibly do with the technologies in order to improve their products or design new products. Number 3, companies say we cannot use specifically trained AI, so AI for us, because, for example, when we're using quality control, we only have maybe 100. We can only take 100 pictures of corrupted, of misproduced items, or maybe only 50, maybe only 20. We can only produce a very small number of these pictures, so we don't have enough data to train. We cannot train our own systems to do quality control, for example, for our companies. And this was completely true longer ago, and in some cases it still is true that you need lots of data to train. But 3 important innovations have open possibilities to work on very small data sets. These 3 things are pre-training, few-shot learning, and synthetic data. It's difficult to explain this quickly, but maybe you take a photograph of this if you have this problem that you don't have enough data, and you can ask me later or ask other experts which you will have in the Merantic space today who can help you with this. So number 4, now coming to the most talked about topic, ChatGPT. ChatGPT can only quote what it has read. Some people are also comparing it with a parrot or with a library of knowledge, and this is just completely untrue. It actually can not only quote it, but it cannot quote what it has read. Sometimes it can, but this is not reliable, because this kind of software does not save its knowledge in a database on a hard disk as conventional software would do that. So we constructed in another company of mine, FactFinder, we constructed a semantic search 10 years ago. This was built on so-called ontologies, and ontologies are like 2 objects and relations between them. So like that was for the travel industry. So it was like if somebody says they want to go to the beach, then they want to have it warm also. If they want a hotel for children, the hotel also needs to have, for example, children's chairs at the tables and these things. So there were always relations like that. These new semantic processors like GPT are storing knowledge in a completely different way. The first thing is, how do they store words? They don't store the words, they store a position in a multidimensional semantic space. So, sorry, multidimensional means not only 3 dimensions, but some more, but some more dimensions. But let's take a look at it from 2 and 3 dimensional spaces. Normally you have like 300. So this could be a 2-dimensional semantic space for words. And what you can see is, for example, the yellow points up there. There is microwave, oven, refrigerator, LG and GE. All these things kind of belong in the kitchen. So an oven, a microwave, and a refrigerator are somehow a little bit connected to each other, much more at least than, for example, color, which is down here, or the shower on the left-hand side, or a drill or something on the right-hand side. So the the knowledge base is not stored in words, but it's stored in positions in a 300-dimensional space, and everything that is close to each other has some relation to each other. Sorry. That has the advantage that if you remember something, then you remember maybe not exactly that, but something similar also. And you can say that two sentences have similar meaning, even though they're completely different words in them. Now, also the distance. So when you have a multidimensional space, you can have vectors, so a direction and a length, and the distance and the direction also has a meaning in these vector spaces. And so when you take the distance between two items in there and you have a similar kind of relationship, then it will have the same distance, the same vector, the same direction, the same distance. So this has been tried for many words. For example, here France, Paris, the same distance, the same vector is for Italy, Rome, Japan, and Tokyo, for example. Okay, so it does not store words, it stores the positions, so it cannot cite the words precisely. Second thing is the transformer. Also, the sentences are not stored. It stores the relationship in sentences. And here it has stored that it is most probably relating to animal and not to the other words here. So when you take a look at this is a little bit similar to the human brain. When you take away a part of the human brain, it is found out about 100 years ago. When people had brain injuries, they lost part of their brain. It was not that they forgot certain things, but they were memorizing everything less good. It's kind of a holographic memory. And so you could not do something I don't know what happened. You could not operate something away, and then suddenly somebody cannot drive anymore. They cannot do many things anymore, and they can still drive a bit. And that's just the same thing for the transformer memory in GPTs. Yeah, sorry, for the transformer memory in GPTs, it does not memorize the sentences. It does not memorize the words. It memorizes kind of an image of that, a holographic image, and tries to reconstruct every time it types out a text. It reconstructs things from its idea of how the world should be. It will not take any citation from any kind of database. It cannot. So when people say ChatGPT should quote its sources, it cannot quote the sources. It does not have any text. It can quote sources it finds on the internet when it gets access to the internet, but these sources could be the right ones. They might not be the right ones. Why it has come to this conclusion. Okay, so I have one more thing. Number 5 is misconception. Europe has a say in the world of AI. Currently, this is not the case, or not very much at least. So we are trying to regulate AI in Europe, and the idea is that when we do this in Europe, then the world will follow, and we think that that all the other continents will also see that we are very wise, and they will also limit their AI. What happened in the last years is Europe has lost in importance in the world, and China has won in importance a lot. And whatever we regulate here will not stop the others. So the regulation is partly okay, but the high-risk part should be revised, and I hope it will be, so that the GPT kind of technologies, general-purpose AI, is not kept in that part. Okay, coming to the last slide. In the next 20 years, AI will change the world more than it has been changed by all other technologies together in the last 100 years. The founder of Sun Microsystems, Andreas von Bechtelsheim, said that. Actually, I believe he's true, and it might be less than 20 years now. And it's very important that we in Europe also keep up in the race. Thank you very much, and I'm ready for questions or questions by LinkedIn if we don't have time.
All right, thank you very much, Carsten. please. Please, some applause for Carsten. Thank you so much for an amazing presentation. Incredible insight into what's driving research with AI, developments in AI. Thank you very much, Carsten. Any questions?
Hello. Hi. Carsten, I just wanted to ask, so transformer models were released in 2017, I think, which is about 6 years ago. What do you think the big models are for the next 5 years or so? Where do you think it's going after generative AI?
Well, so I mean, really disruptive innovations come so suddenly. It's not something you can really predict. So I worked on improving the word-to-vec kind of tools, of concepts to make them multimodal in 2017-18, and then suddenly Transformer came, and Transformer was doing everything I wanted, but so much better. And I did not see it coming. So it's really difficult to say what will happen in the next years. So what we have to see is that out of these innovations, so currently the innovations are just like the core technology, and not so many product inventions have been made. So when you look at the motor, for example, the normal combustion engine, that was invented in 1864 by Nikolaus Otto in Köln-Deutz. And his Deutz Motorenwerke sold about 5,000 motors together in all the time until the car came out, which was like 20 years later. And suddenly the world changed, and many people needed motors. But before that, a motor was just like a different kind of steam engine, a bit smaller, a bit more effective, but using strange fuel, not wood, not coal, but gasoline. But without the motor, we wouldn't have cars, we wouldn't have airplanes. If you put a steam engine in an airplane, it cannot fly. So I think the big changes we will see in the world will rather be the applications that come out in the next years, and there will be many. I can elaborate on that, but maybe there are more questions.
Any more questions? Well, thank you very much. Well, thank you very much for explanation, and thank you very much for going so much into depth. I believe our time is up, but for more questions, please feel free to contact him directly. Or again, if you missed part of this presentation or would like to rewatch it, it's on our YouTube channel. Thank you very much, Carsten. Thank you for attending, and thank you for sharing your insight.